CloudDB, shaping your new normal.
Welcome everyone to the 2021 APAC Groundbreakers Virtual Tour by Apaco UC. This year our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 18 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. This way you'll be able to access the replays to watch at any time until December 30. I would like to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers, and your main sponsor, CloudDB. Now for today's session, Developing and Deploying Oracle Database.NET Applications in Kubernetes by Shay. Please feel free to ask questions at any time by using the chat window in your right lower corner of your screen. And Christian will be answering our questions by the end of the session, if any. If you have any technical issues or any problems with the session, please feel free to use the same chat window to let me know, and I will try to help you the best I can. Now, without any more delays, I would like to leave you with this amazing session by Shay. Christian, the room is all yours.
Oh, thank you so much. Hi, everybody. As you mentioned, I'm a product manager at Oracle, and today's session is going to talk about how you can develop and deploy a .NET application into Kubernetes. So without further ado, let's get started. So today we're going to cover a little bit about microservice architecture in Kubernetes. And then we're also going to discuss a new feature / product called Oracle Database Operator for Kubernetes. Talk a little bit about Oracle Data Provider for .NET Core. And I'll do a demo using a shopping cart application, which I will connect to an Oracle Autonomous Database and push into a Kubernetes cluster. Okay, with that, let's get going. So most of you probably already know what a microservice is. I'm pretty sure it's a very popular topic, but let me just read this quote here. Microservice architecture is an approach in which a single application is composed of many loosely coupled and independently deployable similar services. Let me quickly turn off my camera so that we get a little bit better bandwidth here. So what does that mean? So microservices have well-defined APIs, meaning, once you know what they are, they don't change. They can change, but they evolve. You can use older versions of the APIs. They tend to have private data sets, meaning you can't just access the data yourself. You have to come through those APIs. They facilitate independent development and deployment, meaning that individual microservices can be worked on by different teams at different paces, and they can deploy, whenever they want, whenever they're ready. And because they're independent, because the microservices are independent of each other, you can do that at different times and at different paces. The bounded context of a microservice implies that that you focus on a particular small area. For example, in this example, it uses sales as an example. And so a particular microservice is not crossing over and working on lots of different areas and causing it to be tied into all those areas at once. The idea is to be very bounded. And then finally, loose coupling across microservices, meaning that there's not a tight connection between each individual microservice. They can be pushed out and developed independently, and there's no tight coupling in between them. So typical microservice architecture, it looks like what you see on the screen here. There's an API gateway which takes all the different web service requests or service requests coming in, and routes them to the correct microservice that has been implemented for that request. So in this case, we have a catalog service, we have an order service, we have a customer service, and calls can come in through the API gateway and call these services, and they can call each other also. So you can see there that there's something called a horizontal scaling, which is where each of these services can be running on lots of different machines. You could have 20 catalog services, 100 order services running on different machines. And that's horizontal scaling. And then the y-axis scaling is what microservice architecture implies, which is that it's very specific to a small area, like an order service or a catalog service or a customer service. And then the z-axis scaling is the database scaling that you see, the sharding that you see at the bottom there. So that uses either a geographic location or a key to shard the data into different shards. So you may have a geographic split in your data. Asia may be in one set, and the North Americas may be in another, or you may use a key to do your sharding. So some of the benefits and challenges of microservices. So benefits, you can use different technology stacks for each one. It doesn't matter. They're independent. The development is faster because they're independent. So you basically have a smaller piece to develop, and it can be faster. You can deploy and release at your own decision, and it's independent of the other microservices. And then the potential to achieve maximum high availability and scalability. That's true. However, it is important to note that if you do it wrong, you'll actually end up worse than you would have been because of the fact that, if you have a whole lot of microservices and something goes wrong, now you have a whole lot of failure. So if you don't handle it correctly, you can multiply the failure scenario and end up with worse availability. So freedom to choose different data models. So some of these could be NoSQL, others could be the relational database and cloud native model, which is basically, this is designed for the cloud, as you can see. And then challenges here. Because there's a lot of chatting going on, lots of communication between microservices from the outside world, there's an increased amount of communication and latency involved. And the development can be more complex. Tracing and correlation, that's a big one because a message may come in through the API gateway and then traverse multiple web services before an error is reached. And how do you log all that? How you correlate that can be tricky. Resiliency and recovery, that's a very key issue. If you don't handle automated recovery, then the point is moot. You end up in a worse situation than you were if you use a monolithic application instead of a microservice. And data consistency and data management is always a challenge. You have multiple data stores. How do you keep them consistent? How do you manage it? Okay, so moving along to Kubernetes. So Kubernetes, I'll read that quote. Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. So Kubernetes takes containerized application, manages them automatically, it orchestrates them, moves them, scales them out, etc. So it's great for high availability because you can just spin off more containers. Disaster recovery, you can just, like I say, spin off more containers. Horizontal scalability, as I mentioned, you can just keep adding them. And the goals are issued in declarative configuration inside of YAML files. Okay, so Kubernetes is ideal for microservices, and these are some of the terms that you may see me using as I'm talking about my demo in particular, but pods are the big one. So that's a runnable unit of work, container images developed by different teams into a single deployment unit. It's usually one or maybe two containers in a pod. Services are an abstraction that defines a logical set of pods and a policy by which to access them. Load balancing, naming, and discovery isolate each microservice from each other. And namespaces provide isolation and access control so that each microservice can control the degree to which other services interact with it. And there's an API registry that tracks all the available services and the resources they expose. Okay, so the Oracle Container Engine for Kubernetes is available to you on your Oracle Cloud Console. You just need to go to the Developer Services link and click on Kubernetes clusters. Once you're in there, it's very easy to create a Kubernetes cluster. You just click on the Create Cluster button. And they have a quick workflow that has you up and running, I think, in something like 5 minutes. It's pretty cool, actually, how fast they are able to do that. So once you have your cluster created inside of Oracle Cloud, you need to be able to do work on it. So the tool that is used to do work on a Kubernetes cluster is called kubectl. It's a command line tool, and it knows how to connect to the cluster. You don't have to keep logging in or anything. And you just issue commands like kubectl get pods, and that'll tell me what are the pods inside of my Kubernetes cluster. But in order to do that the first time, you need to provide the authentication information so that kubectl can authenticate and connect to your cluster. So in order to do that, when you go up to the Kubernetes page up on the Cloud Web Console, you will see a Access Cluster button, as you can see in the screen there on my slide. And when you click on that button, it will give you a choice of either connecting via Cloud Shell, and Cloud Shell is a command line that is available right there on the console, or local access, which is what we're going to be doing because we're doing .NET Core development locally. So you need to be using kubectl on a local, use it locally. In any case, I chose local access, and then you can see that it provides some commands that you need to run to basically set up what's called a kubeconfig. A kubeconfig is a config file that has the authentication information necessary to connect to the cluster. And this is an example of what they will give you in this little window here that you need to enter in. In order to do this, you will have to install the OCI command line interface, OCI CLI. And you can see that there is a link up on that page that says download it here. So first download OCI CLI, use that to execute the command that they provide. And then once you've done that, you will have a kubeconfig file. And then you just need to put that in the path so that there's a kubeconfig environment variable that needs to be set. And once that's set, then kubectl will know how to connect, and all your commands will just go right to your cluster. All right, so that's how you manage the Kubernetes cluster with kubectl. Now, what if you want to use a database from that cluster? You may want to have Oracle databases inside of containers. You may want to have your apps running in the containers connect to a Oracle Autonomous database that's located up in the cloud. And so there's something called a Kubernetes operator. So an operator, I'll read the quote, operators are software extensions to Kubernetes that extends the Kubernetes API to manage complex applications and their components. So Basically, Kubernetes is already built to handle stateless applications very easily. It knows how to take a relatively stateless application, and basically when something goes wrong, kill it, spawn new instances, clean up, and do all of that automatically, okay? But what about in the cases of databases? Because databases are complex, they're stateful. When a database has problems, you can't just, delete it. You have to handle, you have to deal with the cleanup, and you have to have specialized knowledge of the database and what's in the database to be able to do that cleanup. And so normally you would have, if this was a monolithic application or something, you might have an application administrator or a database administrator who would have to deal with that. But or otherwise known as an operator would have to deal with that. But in Kubernetes, everything should be automated. So there's a concept of a Kubernetes operator, which is essentially a custom configuration and custom resource that knows how to operate on these stateful applications and do the right thing when something bad happens, or when you need to do something to that, not just bad things, but when you need to do something on that app, on that stateful application like a database, it knows what to do. So that's where we come to the Oracle Database Operator for Kubernetes. This is pretty new, came out in October, and the link that you see at the bottom of this slide is where it lives. It's open source. It's up on GitHub. So you can go to GitHub there and get it immediately and start using it, not just on Oracle's cloud, but on any cloud. In any case, it's very easy to get to use. It works with containerized databases, like I mentioned, like if you have a database in every container, for example, and it also works with autonomous database. So it gives you some lifecycle operations like provisioning the database, binding it to an existing database, start, stop, and terminate the database, scale up and down, upgrade and patch, and observability. So aside from container databases and autonomous database, on the roadmap are on-premise databases. So those are coming from what I understand. So stay tuned. But this is the link to the GitHub page for autonomous database. All right, so how do you get this installed? Let's go back to Oracle's Kubernetes. Actually, you have to do this for any Kubernetes, but the demo that when I show you some demos, I'm going to be using Oracle's Kubernetes OKE. But in any case, so the prerequisites, which could change, you should definitely go to if you're watching this at some later date on a replay, you should definitely go to this GitHub site and verify all of the prerequisites because they probably could change over time. So, but right now, this is what the prerequisites are. You need to install the cert manager, and they provide a YAML file for you to do so. It's very easy. You just use that kubectl, apply, -f, and then the path to the YAML file, the link to the YAML file. And then you need to give access to OCI, give access to the Oracle Cloud. You need to generate a config map and secret to do that so that the database operator can get to the Oracle Cloud, or you need to set up what's called an instance principal. And then once you've done that, then there's a quick install of the Oracle Database Operator. They provide a bunch of example YAML files. So you just take one of those, the Oracle Database Operator YAML file, and you say kubectl apply -f Oracle Database Operator.yaml. And then once you've done that, I included this in the slide because it was very helpful to me, which is that these are a couple commands you can issue that will tell you what's going on. Kubernetes can be a little tricky if you don't know how to look at logs. So you need to learn how to look at logs to be able to tell what's going on. So kubectl get pods -n Oracle Database Operator system will tell you if the pods came up properly. And kubectl logs -f pod and then the pod name -n Oracle Database Operator system will show you logs of what's going on. I ran into some problems where I accidentally added an extra quote on a password, and it just couldn't authenticate. And when I looked at the logs, I realized what I had done incorrectly, and was able to correct it. So this is very useful. Go back and take a look at the slides when you finally try this out. Okay, so to provision an ADB, you would look at the upper right-hand corner here, config samples ADB autonomous database create YAML. So you would get that from GitHub and you would modify it with the compartment OCID that you have. You would get that from your Cloud Console. Step 3 here, you need to create a Kubernetes secret that has the password for the database that you want to use, admin password for the database that you're going to provision. And then you modify the YAML file with the compartment OCID and with the secret name. And then you run that, you execute that YAML file, kubectl apply autonomous database _ create, and that's it. You can verify it using the OCI command line, or you can go to the web console to see that the database instance has been provisioned and is coming up. And then to bind to an existing ADB, you go to this in GitHub, autonomous database bind. So this is an existing ADB that's already going, and you just need to bind to it. So again, you get the database OCID from the console by clicking on the display name and looking at the OCID, copy it, find that YAML file, autonomous database bind, and modify the OCID, apply it with kubectl, and that's it. And then you can say kubectl get ADB, and it'll tell you that it's available. So this will make an existing ADB available to your applications that are going to be in your Kubernetes cluster. Now, I'm not going to talk too much about the other options for a database, which is a local instance of the database inside of each of the containers or one of the containers. But for this demo, we're just going to use an existing ADB. All right, so very important thing for database applications that are connecting to autonomous database is they need to be able to get a hold of the wallet. Because right now, you need to use in most cases, you need to use a wallet to connect to your autonomous database. So you need to create a instance wallet password, and then put that Kubernetes secret into the or autonomous database _ wallet.yaml file. Now, in this example, in one example earlier that I did, we put the password on the command line just for the sake of a demo. But I wanted to make sure that I pointed out that passing passwords on the command line is not a recommended practice. Normally, you'll put your password in a vault and get it from there. It will not be passed on the command line. It's not secure, or it's less secure anyway. Okay, so before I move along in this session, let's take a look at the Oracle Database Operator GitHub site. Okay, so this is the Oracle Database Operator GitHub site as of December 2021. As I say, things can change. So if you see something different when you go here after watching a replay video, that's fine. Just make a note, be aware of that. There's some time that has passed. So in any case, this is very great. The documentation is awesome here. And so there's a major prerequisite, the install cert manager, which I mentioned, and they tell you exactly how to do it here. And then a quick install of the operator. It's very easy. Okay. And then once you've done that, now it depends on how you're going to use the operator. If you're going to use autonomous database like I am, you go there, and then you'll see there's one more set of prerequisites for autonomous database, and you can see that you create the config map for the information about how to connect to the cloud. Or you can set up instance principal, which I won't get into today because I don't have time. But once you've done the prerequisites, then here are the help to how to bind to an existing database, and importantly, how to use a wallet. All right. So in our demo today, what we're going to do is we're going to have an app that's going to get the password to the database from the environment, and it's going to get the wallet from the file system. So how is that going to work? Well, you're going to find out. But basically, our app is going to need to be able to look at the environment and get the database password, and it's going to need to go into a particular location in the file system for the container and find the TNS names.ora file and the wallet to be able to connect to the cloud. So we're going to have to make sure that that's all set up in our application, and you're going to see how we do that in our demo. Okay, so that's it for the operator. Let's go back to the slides. And let's talk about .NET now. So we've already been talking about, Kubernetes. We've been talking about the Oracle Database Operator, which makes the database easily available to applications on Kubernetes. So now let's keep going and let's talk about .NET, because that's why you came here. You wanted to hear, how do you do it with .NET? So .NET Core is lightweight, and it's cross-platform, which is really key because even though it does run on Windows and Mac, it runs on Linux, which is where Kubernetes lives. So if it weren't for that, we wouldn't even be talking about this. But .NET Core runs on Linux, so it's going to be able to work in the Kubernetes cluster. It's a rewrite of the .NET framework from days gone by, like all the way back to 2000. It's a new rewrite. It's been around for a while. And there's something else, another term you should be aware of. You may or may not use this, but it's called Entity Framework Core. And that's Microsoft's object relational mapper. It basically allows you to map classes to your database. And for this particular demo, I happen to be using that. So I just wanted you to know that there is Entity Framework Core involved. You don't have to use it. You can connect directly to the Oracle database. But how would you do that? So how do you get database access from .NET Core? Well, the answer is something called Oracle Data Provider for .NET Core. So this is our data provider, similar to, say, JDBC, or JDBC Thin, really, is the closest analogy. But in any case, it implements Microsoft standard ADO.NET Core data access, and it provides native access to the Oracle database. So it's not just like with ODBC or something. It's not just, a least common denominator database access. It's actually all the Oracle advanced database features are available to you. It's completely managed code. It's very small. It's similar to thin JDBC, meaning it's all written in managed code and it's small and it's just one DLL. So you can get it from what's called the NuGet package manager. So that's easy. If you're using Visual Studio Code or Visual Studio, that's easy. It's integrated directly automatically with Visual Studio. You just go to the NuGet package manager, type in Oracle, and you can find our data provider there. And the one you're going to need is Oracle Managed Data Access.core. And then if you happen to be using Entity Framework Core, like I will be today, you need Oracle Entity Framework.core. So I'm going to do a demo in the next 15 minutes that shows how to develop a .NET microservice. And my demo is a shopping cart demo. So my microservice has a get, a put, a delete, has a delete web service. And basically it, if you're using this from some other app, basically you can put items into a shopping cart, and if there's no shopping cart for you yet, it will create one, and then you can ask for the cart back, and you can delete items from the cart, and you can delete the whole cart and things like that. And multiple, you can have multiple shopping carts inside this microservice going at once. So how did I implement this? Well, there's a really nice template called ASP.NET Core Web API Project Template. And this is available both in Visual Studio Code and Visual Studio. I'm going to use Visual Studio today just because it's a little easier to follow. It's less command line stuff. So it might be a little easier to see what I'm doing. But you can do it from Visual Studio Code as well. So it's called the ASP.NET Core Web API Template. And then I implement, I have code that already implements get, post, put, delete. And I happen to be using Entity Framework Core for data. So I have a class called I believe it's called a cart class, and I have a cart item class. And then these are mapped to an Oracle database table. Now the app gets containerized in Docker. All right, so it's built into a Docker container, and it needs to get the database username, password, and the database name so that it can connect to the database. So these are all going to be in the environment of the app, but I'm not going to put those there. Those are going to be put there by Kubernetes, and you will see how I configure the app deployment. And then the app also needs to get the wallet from the file system. So similarly, Kubernetes is going to put the Kubernetes secret, which has the wallet and the password. It's going to put the wallet in the file system and put the password, the Kubernetes secret password, into the environment. Then we will test using a browser or a tool called Postman, and Docker will be used to build the Docker container. After I build the app and I get the files for the app, I'll build the app into Docker and push it into a container registry. So I'll be using the Oracle Container Registry, which I created an instance of a container registry in the Oracle Cloud for myself, and I'll be pushing to it. But you could use other container registries as well. So in any case, as you may have seen, there's YAML files that you use kubectl to execute to do things like deploy an app. So on the right-hand side, you can see my cart deploy YAML file. So if you take a note of a few key things about this YAML file, the first is that it points to my Oracle container registry for my container image. That's down here under containers, next to image. You can see it there. Okay, so that's what's getting pushed into the Kubernetes cluster. And then you can see that I have my autonomous database has a user named cartadmin, and I have a database called myalwaysfree_hi. And then the password is also going to be in the environment. This is what env stands for, but that's going to be coming from a Kubernetes secret that I created already. So that's managed by Kubernetes, and it basically puts the password after it's deployed into the cart pass environment variable. Then you can see that I have an instant wallet secret name, and that's going into a volume, which is a mapped drive. So you can see that it's going to be mapped to my dbdemo/creds directory, and that will be visible. All of this is going to be visible to the app. All right, so let's go ahead and bring up Visual Studio here, and let's take a look. Okay, so I have an app here, shopping cart service. Now, let me open up a new project just so you can see how you get here. So you can take a look. If you type in web API and hit return, you will see that there's a template called an ASP.NET Core Web API template. So that's what you probably will use. I'll just quickly create a bogus one here. But primarily, you will see that there's a startup file, which has some information about the configuration, and most importantly, a controller. So they have a demo here built into the template for for a web service that just provides a random a weather forecast. But you're going to need to modify all this to not only respond to requests for your app, but also to access a database that you have. So that's what I'm going to do. And then let me go to my shopping cart app, recent projects, shopping cart. All right. So now this is a more completed application. So one thing I will point out is if you look over here under dependencies, you will see that that I have a couple dependencies that are important here. So I have Oracle Managed Data Access Core for my data access, and I'm using Oracle Entity Framework Core as an ORM. Okay. Now, if you take a look at the startup file, you can see that I have some entity framework models here. I have a cart. A cart contains a list of cart items. This is what a cart item looks like. And cart context is where some of the database stuff takes place. But more importantly, if you take a look at the startup CS here, you can see that this is where I am setting up my connection. So you can see that right now I'm going to build this to run locally, you see. And I happen to have my my wallet located locally here. And furthermore, on the local machine, I have my environment set up already with my username, cart user, cart pass, and cart DB. So this will run if I run it locally. Okay. In fact, let me show you one more thing, and then we will run it locally. But when this gets into the container, I'm going to have to build this using the location on the container, which is db demo creds. That's where the TNS names.aura file is located and where the wallet file is located. So I will have to remember to change this, rebuild it, and then redeploy it, and then deploy it to use the correct path. There's other ways you can do this that are much more elegant, develop time and release time configurations, but I'm not doing that here. Okay, so the last thing I wanted to show is the actual controller, cart controller. So you can see that I have different commands. So git, this is the git command, and so I'm doing some. This is entity framework here. I'm doing some different commands to get the cart, to post the cart item, to put a cart item, and to delete a cart item. Okay. And your app the app that you do will be very similar to this, but you might not use entity framework for the database access. That's all. So let's go ahead and build this. And then let's run it. Start without debugging. And it's going to bring up a web browser. Okay, but it turns out that my service is listening on a slightly different URL than this, but it's running right now. It's running a local instance of my app on this port. That's the most important thing. So I can, let's see, I have a link here. I have a link here that will go there, and you can see that, yes, this is the cart right now with some items in it. And I can use Postman, for example, to look at this in a more elegant way. Let me see, the results are down here. You can look at it in JSON. And furthermore, if you use one of the more modern, depending on how you set up the web API framework, Swagger, there's a lot more elegant web browser-based ways of looking at your data. But you can use this. You can try posting data. I'm not going to do it here for lack of time, but you can see that I have some items here I could, in my body here, sorry, raw, JSON. So I could change this and put a new cart item and try posting to it. But Postman is one possible tool you could use when you're testing this. Okay, so now we've built the app. We've proven that it works. Now I need to go back in and I need to change that. Where is it? I need to change the, let me stop. Let me go to the Server Explorer here, go in here to the startup and change this to what we're going to be using when we deploy to the container, okay? All right, so now we're going to be using, this is what the container will see as the path to the wallet. This will be, the password here will be provided by the secret in Kubernetes. So let's build this. All right, so now we've built it, no errors. And let's deploy it. So let's not deploy it, but let's publish it to a set of files. So we'll publish. And we're going to publish just to an output directory. And the way I happen to have done things here is I put all of these into a tar file, and my Docker file will parse the tar file. So let's add this to an archive called publish.tar. Here it is. I'm going to cut this and place it in my Docker directory. So now I have a publish.tar file and I have a Docker file that looks like this. So I'm using the Microsoft ASP.NET image. I'm adding the publish.tar file to the app directory. So this is automatically extracting it, by the way. And then all that's left is I'm calling the shopping cart app on port 5000. So let's go ahead and use Docker. Let's see. I think I might have the commands in here. Let's see. Docker build. Okay, let's see. Failed to compute cache fee not found. Let's see. Why did that happen? Let me see. Is there something wrong with that file? Let's see. I'm going to give this a couple seconds and then I'm going to have to skip it. This has never happened before. Let's see. Publish.tar. Okay. Let's see. So it's thinking that it can't find that file. Is it not named correctly? No, it's there. Okay, is it? Okay. All right, well, I can't publish this up there, but I already have one up there that it would have replaced, so we're okay. Let me show you the other commands I was going to execute. So we have, where is it? So there was Docker build, Docker tag, and then Docker push. So these are the commands I was going to execute, but somehow the build is failing, and I am not sure what happened. Something very strange happened, and I've never seen that before. Sorry about that. So anyways, the good thing is that I have already pushed this into my container. So it's already there. So now I'm going to go to a compute. I have Windows running in the cloud, and I'm going to quickly come on up here and switch to YAML files. So now I have, I want to show you that I do not have any pods in my Kubernetes cluster. Okay, but if I open up this cart deploy, as we showed earlier in the slides, I am now going to deploy my application. So it's going to be using this image. Unfortunately, we weren't able to push it up there. I'm sorry about that, but let's go ahead and apply cart deploy. Okay, and then we can show that the pod got created, and I hope I don't jinx this, but show that the pod got created and then it's running okay. Okay. And now the last thing that we need to do is to do port forwarding so we can test it. So I'm going to do port forwarding on port 500. And you will be able to see when I run it here, it should execute. There we go. And exactly. So one other thing I wanted to show before we go is just a couple of these other commands for troubleshooting. So kubectl logs. This is a good way to see if my deployment had failed. You can look at the logs here. So there's a couple warnings here, but no errors. And the last one is this ability to basically go into the shell for the container. This is really useful. So I'm actually going into my shell, and it'll take you directly into the working directory. So you can see there's my application. There's the shopping cart DLL. And if I go up a directory and I go into DB demo, creds, there is my tnsnames.org and my wallet. And furthermore, if I say set and look, you can see there is my supposedly secret environment variables. Okay, so that is a very whirlwind tour of how to deploy the .NET application. I have, when I provide these slides to APAC's Groundbreakers, there will be some additional slides at the end that will show you how to do some of these things in more detail. So a few extra slides are at the end that you can take a look at that give you some more commands that might be useful to you. So these are some of the links that might be useful to you. In particular, my email address. If you're watching this and have a question, you can do that. You can also ask the question here in this session if you're watching it live. So with that, I'll turn it over to the moderator and see what he has to say.
Hi, Christian. Excellent presentation as always. Very educative with a lot of information that for sure will help a lot of people are in the community, not in the Asia Pacific, but also all the communities around the globe. I cannot see any questions coming right here. Just giving a few seconds to see if anything comes from the Facebook. Basically, if you have any questions that Christian mentioned, please feel free to contact him in his email on the screen. If you're watching the replays, you can also ask questions after the presentation. And saying that, no questions coming through at the moment. In that case, thank you again, Christian. 2 sessions in a row the same day. Thank you so much for your time. Have a wonderful evening over there in the States, and please take care and be safe with regards to COVID and all this craziness outside.
My pleasure. Thank you for inviting me. I really appreciate it.
Thank you, Christian. Have a wonderful evening. A wonderful evening, morning, afternoon to everyone, wherever you are. Bye-bye.
Bye, everybody.
CloudDB, shaping your new normal.